Okay, I want to go over the solution to the sunset problem. Now, in this problem, we were told that if we're lying down on the beach, so right here, if we're lying down on the beach and we watch the sunset, okay, as soon as the sun sets, if we were to stand up, we could watch a second sunset. All right. Now, when we're lying down or any time we're looking towards the horizon, our line of sight will hit the Earth's surface at a tangent. Okay, so the Earth is a sphere, which is basically a circle. So our line of sight hits the surface of the Earth at a tangent. When you have a tangent line to a circle, that's at 90 degrees. And we learned earlier that 90 degrees will go right through the center of the circle, giving us a radius. So the same thing for this second line of sight. Okay, and there's the height of the person. Now, in this problem, we were given the height of the person, or the height of the elevation to their eyes for the second sunset. We were given as 1.70 meters. We were also told that if you were to time how long it took between sunsets, the time between the sunsets was 11.1 seconds. So using this information, we want to figure out the radius of the Earth. All right, so that was the problem presented to you guys. Now, the diagram that you want to get is what we have right here. All right, here's the Earth. Here's the first line of sight to the first sunset. There's the second line of sight, second sunset. And then from there, we can see the radius, and height. But this initial diagram, what it really gives us and what we want to focus on is this part right here. All right. Now I'm just going to redraw that down here. This right triangle that we're focusing in on, I'm just going to rotate it a little bit here. Okay, so this side right here is r, and then the hypotenuse of the right triangle is r plus h. This angle in here, theta, it took 11.1 seconds for that angle to form. Okay, that arc length took 11.1 seconds to form. So we can figure out what the angle is. So theta is to 11.1 seconds as, if we started here, like if we imagined the first sunset and we just stayed laying down, we didn't get up, and we wanted to watch a second sunset without moving, then the sun would have to, and let's pretend that the Earth's not moving here, the sun would have to go all the way around and set again. And that would take 24 hours. In the meantime, the arc length the sun would go through in that case would be 360 degrees, or angle that it would go through. Okay? So theta is to 11.1 seconds, as 360 degrees is to 24 hours. So we're going to use this relationship to figure out the value of theta. We have hours in the denominator and we have seconds in the numerator. So those units are not going to cancel out. So I need to convert one or the other. I'm going to convert hours to seconds. I know that there are 60 minutes in an hour and 60 seconds in a minute. So hours will cancel, minutes will cancel, and then I'll have seconds and seconds. Seconds will cancel, and I'm left with degrees, which is the right unit that I want for this problem. When I do the math out, I will get 0.04625 degrees for the angle. Okay, we're going to need that value later. Okay, going back to this right triangle. Right now, I know the height and I know the angle. I need to find r. So to find r, I'm going to use some right triangle trigonometry. Just a quick review of right triangle trig. If this is the angle I'm talking about, we have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. In the case of this triangle, I have the adjacent side is r and the hypotenuse is r plus h. So I'm going to end up using the cosine function to solve for the radius in this particular problem. So when I use cosine, I get cosine of theta is equal to the adjacent side, which is r, divided by the hypotenuse, which is r plus h. Okay. Again, I know h and I know theta. That means I have a number here and I have a number there. The variable I'm trying to solve for, r, is in two places. So I have to do some algebra to get the radius alone, to get that variable alone. So the first thing I'm going to do is I'm going to multiply both sides by r plus h. So when I do that, I'm going to get cosine theta times r plus h equals r, right? Next, I'm going to multiply cosine theta through to get rid of these parentheses. When I do that, I'm going to get r cosine theta plus h cosine theta equals r. Okay, I have an r term on this side. Okay, this is just r times a number. Like you could say, like if this was 2, if cosine theta came out to 2, then that would be like 2r plus a number equals r. All right, so I have r on the left of the equal sign and r on the right, so I need to collect like terms. So what I'm going to do is I'm going to subtract this from both sides. When I do that, I get h cosine theta equals r minus r cosine theta. Okay, so I'm just doing algebra right now. All right, I have r here, r here. I can pull an r out and put some parentheses there. So when I do that, I get r1 minus cosine theta. Okay, now I have r in just one location, right? So I can solve for r now, get it alone by dividing both sides by 1 minus cosine theta. So when I do that, this is what I get. Okay. So I have a number times a number divided by parentheses 1 minus a number. So I have all numbers over here. I can finally solve for r. Now I'm just going to plug in the numbers over here to solve for it, to show you the work. All right, 1.70 meters times the cosine of 0.04625 degrees. Make sure your calculator is in degree mode. Divided by 1 minus cosine of 0.04625 degrees. When I do that out, I will get r is equal to 5.22 times 10 to the 6 meters. Okay, so there's the solution to the problem that we had to do, finding the radius of the Earth based on height of elevation and time between two sunsets. Now, if I were to give you a similar problem, but I gave you different information and asked you to solve for something else, how would you go about that? Well, the first example that we did like that was I gave you the circumference of the planet, and then I gave you the height of the elevation, and I wanted you to figure out what was the time between the two sunsets on whatever planet. Okay, well, the equations that we end up arriving at, this equation and this equation down here. Okay, so we have cosine theta equals r over r plus h, and then r is equal to h cosine theta divided by 1 minus cosine theta. So this one is based on the angle, and then this one's based on the radius. I could take this equation and I could give you, in a problem, I could give you the angle and the radius and ask you to solve for height. So it'd be similar to this one solving for r, but you'd be solving for h instead. You could actually go right from this equation and solve for h. You could do h would be equal to r times 1 minus cosine theta divided by cosine theta. I could give you the circumference of the planet, the height of elevation, and you'd have to solve for the time based on taking the circumference, dividing by 2 pi to get the radius. I could give you the diameter of the planet. You could take diameter and divide by 2 to get radius, and then use that to solve for the time between the two sunsets. I could give you the time between the two sunsets, the radius of the planet, again, ask you to find height. So I can give you the different things to solve for something else, but it's going to end up being these same equations. Okay? So again, these are the two equations, or really, maybe this is the best one to kind of look at as far as solving for other stuff. Okay? This is the best because it only has the variable r in one place, h in one place. It does have the angle in two places, but if you wanted to change that around or get it so the angle is only in one place, go to this equation. Okay? At this point, though, it's just algebra to solve for these things. One thing I will say, though, that you need to remember is, let's say I did give you r and height, and I wanted you to solve for the angle. Okay? To go from cosine theta and get the angle alone, I have to take the cosine inverse of both sides. When I do that, this is what you would write, or what you would get. Okay? The cosine inverse, or inverse cosine, will get rid of the cosine over here, but then you have to write cosine inverse of all this stuff. Okay? So that's how we solve the second problem as far as time between sunsets. Right? Once I know the angle, I know that the time between sunsets, I can plug it into this equation over here. I just need to know what is a day on whatever planet I give you. It's always going to be 360 between the sunsets for the to go around once in one day. And then this time is dependent on whatever this angle is. I hope that helped. If there are any more questions, please email me, let me know. Again, try doing these problems, make sure you're getting the right answers, and review for the test.